Alright everybody, welcome back. This will be the fourth and final operation for the holder part. So, first thing we'll do is create a new toolpath group. And a new plane. We'll go from solid face, and we'll click on this one. And we want the X pointing to the right. This is going to be the orientation of the part. So, just like that. Green check. And then I want to click on the reselect to snap to the corner of the part like that, and green check. And then I want to make this plane current and call it OP4. So OP4, and then I click on the WCS, the C and the T. Alright, so this is the orientation, and this operation is going to take care of the hole, which is a through hole on this portion and a tapped hole down here, and then the slot going through the middle here and the slot here. We'll have to make a couple of adjustments because the tools that we're using are about 62 thousandths wide, and these gaps were modeled at 50 thousandths wide. So we'll make adjustments for that in our toolpaths, just so we can see from there to there, it's 50 thousandths. Alright, so the first thing we'll do is drill the hole, and then we'll cut the slots out. So I'll spot the hole first. It's 221 thousandths diameter. I'm going to go with my 1/2 inch spot drill. My speeds and feeds, 2500 RPM, 10 inches a minute. And I'm going to use a standard drill routine. And for my linking parameters, I'm going to use 230 thousandths as my finish diameter. So minus 0.23 divided by 2 gives me, 115 thousandths deep. My top of stock should be 0. And my retract, notice the retract says minus 1.05. That's from when we did this hole here in the third operation, right? So it still remembers that from the last time we created a drilling operation. So we have to watch out for that, because if we leave that the way it is, we're going to have an issue where the spot drill crashes right through the part. So not a good thing. So we'll change this back to positive 100 thousandths. We don't want any tip comp on the spot drill, and coolant should be on. Green check. Alright, now for drilling the upper portion of the hole, what we're going to do is we're going to use that 221 thousandths drill to come through and down into this hole here, which is tapped, and we're going to use that drill as a spot drill for the bottom portion of the hole, just like we did the spot drill up here for the top portion of the hole. Then after we cut the slot, we'll have a nice deep burred hole. Okay? So, once again, drill operation, and I'll just click on my copy previous point button, check, and I'll go find that 221 thousandths diameter drill. It should be a number 2 drill right there, 221 thousandths. Alright, I'll bump up the speeds and feeds. 85 surface speed and 2,500 chip load. And I'll switch back to a peg drill. And my linking parameters, retract is 0.1. So we can now drop that back down. So let's see our retract. Change that to minus 0.2. No, sorry, 0.1. We're not there yet. That'll be the next drilling operation. 0 for top stock. For our depth, minus 0.275. Now we said that this gap was 50 thousandths, and the tool is going to be a 1/16 thick, which is an extra 12 thousandths divided by 2 for top and bottom is 6 thousandths. So we're going to drop this down another 6 thousandths, minus 0.006. And then I'm going to give it tip comp with 0 breakthrough. Alright, make sure the coolant's on. Green check. So if I do a quick back plot, it's going to bring that drill down and make a spot once we come back and clear out that slot. Alright, so now we'll finish the hole. We'll drill it and tap it. So drill, copy previous point. For this time for the tool, it's going to be a 1024 tapped hole, so the drill for that is going to be 159 thousandths, a number 21. So green check. Speeds and feeds. Just leave it like that. Peck drill. And now we can go ahead and lower that retract to minus 0.2. Top stock is 0. Depth, I'm going to drill all the way through the part. So minus 0.625 for the depth. And tip comp, this time I'm going to give it some breakthrough, maybe like 30 thousandths. And coolant is on, green check. So now I got the drill going all the way through. And I will come back and tap it. So drill, copy previous points, green check, tool, and I misspoke a second ago, it's actually a 1032, not a 1024. So I'll go to my filter to taps, and it should be right here, 1032, green check. I'm going to use 5 inches a minute for the feed rate. Gives me 160 RPMs. 5 times 32, 160. Cut parameters is going to be a tap. Linking parameters. I'm going to go minus 0.6 for my depth. And I'll leave the retract at minus 0.2. And no tip comp on a tap. Coolant is on. Green check. And I'll give it a save real quick. So the hole is done. Now we just have to do the slots. So I have to determine which of these slots I want to do first, right? So with the part in this orientation, it's going to be an end mill that does this top slot. And it's going to be a key cutter tool, or saw, if you want to call it that cuts this slot on the side. Alright, so what we're going to do first is we're going to end mill this slot on the top first. That way there's not excessive vibration. So go with a contour toolpath. I'm going to activate solid selection and single edge. And I'm going to select this edge right here. Green check. So for my tool, it's going to be a 1/16 end mill. Select library tool. Filter to my flat end mills. 1/16 right there. Green check. We'll do a right click, edit tool. Go to my finalized properties. Change it to a 3 flute. I'm going to give it 100 surface speed, and I'm going to give it 5/10 chip load. Plunge rate, it's going to be, I'll just do 40. We'll be outside of the part, so we won't be plunging into material. Alright, so for our cut parameters, we're going to use computer comp. We're not trying to hold a specific dimension here, so we don't need any wear comp or anything like that. It's going to be 2D, and we're going to need to make an adjustment. Again, 50 thousandths wide gap. We do want the center of the tool to follow the center of this slot, and so what we're going to have to do is for the stock to leave on walls, we're going to go ahead and put a negative 0.006. Alright, so that'll adjust the tool a little bit over to make it follow that center line. Alright, I'm going to do depth cuts as well. Do a 20 thousandths depth of cut. And then for the lead in, lead out, going to extend the beginning. I'm not going to actually do an arc in or anything like that. We're not using G41, so we don't really need it. So adjust the start of the contour by, let's say, 75%. And then the end of the contour, we're going to shorten it by 50%. So that's going to make the tool stop right where this end of the slot is modeled. Okay, let's see. Don't need breakthrough, don't need multipasses. Linking parameters. So absolute. So the depth for our linking parameters is going to be, alright, a little more deep than that. So I'm going to say minus 200 thousandths. Alright. And coolant is on. Alright, there we go. Oh, what's that? What's that doing up there? Let's see. It was our top of stock got us again, didn't it? Yes, it did. So top of stock should be 0. Check and regenerate. That looks better. Okay. Now for our side slot. Again, it's going to be a contour. And actually, we're going to need a little bit of geometry, aren't we? There's no edge or anything for that tool to follow. So let's go ahead and draw a line. So wireframe and choose line endpoints. And our first endpoint is going to be at the center of this, the bottom of the hole here. There. And then the other end is going to be the center of the hole up here. Just like that. Check. Alright. So now that we have that, we can actually do our toolpath. So toolpath, contour. I'm going to go back to wireframe selection. Single entity. Click on that guy right there. For my tool, like I said, it's going to be a key cutter. So if we come here to the slot mill, let's see. I'm going to cancel that because I don't know if you guys actually have any tools in there. So in case you don't, we're just going to go ahead and create a new one. So I'll do a right click inside the window here, create tool, slot mill, next. Okay, so my cutting diameter is 1.5 inches. Thickness is 0.062. And my shank diameter is 0.5. Okay. And number of flutes is going to be 12. And that's that. Finish that. So I'm going to bring down the surface speed to about 150. Nah, 200. And my chip load is going to be 1.5 thousandths. Alright, cut parameters. It's going to be computer. Stock to leave on walls. Let's go back to 0. We do not want depth cuts. And let's see. We do want to keep this. And we need to also extend the end of the contour. Do that at 75% as well. Alright, for the linking parameters, for our depth, it's going to be this depth right here minus 6 thousandths. Alright, coolant is on, green check, let's see what that looks like. Back plot. Alright, you probably shorten up those extensions and our lead in, lead out, maybe try 60 on those. This tool's going to move pretty slow, so if we can save a little time, it's gonna save actually a little bit more than a little bit. That looks better. Okay. Looks good. Let's go ahead and save it. And backplot. Or I'm sorry, verify. 3D verify. Bump up the speed. Yeah, look at that. Nice deep bird hole down there. Part looks good. Thanks for watching. We'll see you on the next one.